Ladies and gentlemen, imagine a city where traffic jams are a thing of the past, where traveling across the city takes minutes instead of hours, and where the streets above are free for people, parks, and green spaces. Picture tunnels buzzing with electric vehicles moving silently and efficiently beneath your feet, connecting every major hub with precision and speed. This isn't science fiction. This is the future of urban mobility, a city reimagined from the ground up where technology, sustainability, and human innovation converge to make life faster, smarter, and cleaner. Get ready to witness how Dubai is transforming into a city that moves at the speed of tomorrow. The Boring Company is taking over Dubai, and it's not just a headline. It's a glimpse into what happens when next-generation infrastructure meets one of the world's most ambitious cities. Dubai has always built for the future. The tallest towers, the smartest districts, the boldest ideas. Now imagine that same ambition applied beneath the surface. A high-speed, zero-emission tunnel network designed to eliminate traffic, reduce travel time, and completely rethink how cities move. And traffic congestion is a challenge faced by every rapidly growing city. As populations rise and economic activity accelerates, traditional roads reach their limits. Expanding highways only adds temporary relief. Elevated rail changes skylines and requires years of complex construction. What if the solution isn't above the city but below it? That's where advanced tunneling technology comes in. By building cost-efficient, fast-to-construct underground transit systems, the Boring Company introduces a scalable solution designed for modern urban density. And Dubai is uniquely positioned for this transformation. Its infrastructure mindset is already future-focused. Autonomous vehicles, AI governance, smart mobility platforms. These aren't concepts, they're active initiatives. Integrating an underground loop system into this ecosystem would create a seamless transportation layer. Picture passengers entering climate-controlled stations, stepping into electric vehicles, and traveling directly to their destination at high speed. No traffic lights, no gridlock, no unpredictable delays. Direct point-to-point travel changes the experience entirely. And speed is only part of the equation. Efficiency defines the system. Traditional subway projects can cost billions per mile due to large tunnel diameters and heavy infrastructure. The Boring Company reduces tunnel size by optimizing for electric vehicles, dramatically lowering cost and construction time. Smaller tunnels mean faster boring, less surface disruption, and minimal impact on existing city operations. In a city like Dubai, where aesthetics, precision, and planning matter, minimizing construction footprint is critical, and sustainability plays a central role as well. Dubai has set ambitious clean energy targets, investing heavily in solar power and green technology. Electric transport running through underground tunnels aligns perfectly with those goals. Zero tailpipe emissions reduce surface congestion, and improved energy efficiency contribute to a cleaner urban environment. When integrated with renewable energy sources, the loop system becomes part of a larger sustainable ecosystem. But this isn't just about moving people. It's about unlocking economic acceleration. Faster mobility increases productivity. Tourism improves when visitors can travel seamlessly between landmarks, airports, business districts, and entertainment hubs. Real estate values benefit from enhanced accessibility. Smart logistics systems can eventually expand underground for goods movement, reducing heavy traffic on surface roads. Infrastructure becomes a growth multiplier. And Dubai thrives on being first in architecture, first in innovation, first in redefining possibility. Adopting next-generation tunneling technology reinforces that identity. It signals to the world that urban congestion isn't inevitable. It's solvable. Instead of expanding outward endlessly, cities can build inward intelligently. Underground networks free up surface space for pedestrians, green areas, and autonomous electric fleets. And technology integration would be seamless. Real-time traffic algorithms, AI-driven routing, and vehicle automation could coordinate thousands of trips per hour. Stations could be compact and strategically positioned near major hubs. With electric vehicles optimized for tunnel dimensions, energy efficiency improves while operational costs decrease. The system becomes modular, expandable as demand grows, adaptable as the city evolves. And safety and comfort remain priorities. Modern tunnel systems incorporate advanced ventilation, fire suppression, structural monitoring, and automated traffic management. Riders experience smooth acceleration, controlled speeds, and minimal noise. In Dubai's climate, underground transit offers consistent comfort regardless of heat or weather conditions. And the broader vision extends beyond transportation. When cities solve congestion at scale, they unlock time, and time is the most valuable resource. Shorter commutes mean more productivity, more leisure, more opportunity. Urban planning shifts from reactive to proactive. Infrastructure becomes intelligent rather than oversized. And the Boring Company entering Dubai represents a convergence of ambition and execution. It combines engineering efficiency with architectural boldness. It turns underground space into a strategic asset. Instead of viewing tunnels as expensive necessities, they become high-speed arteries powering the next era of city design. And in a world where megacities struggle under traffic pressure, Dubai has the opportunity to demonstrate a different model. One where innovation moves faster than congestion. By leveraging advanced tunneling systems, electric transport, and smart integration, the city doesn't just adapt to growth. It redefines how growth works. And by leveraging advanced tunneling systems, electric transport, and smart integration, the city doesn't just adapt to growth. It redefines how growth works. And when growth is redefined, the entire rhythm of urban life begins to change. Commutes that once required careful time management become predictable, almost effortless. Business districts that felt distant suddenly feel connected. Residential communities expand outward without sacrificing accessibility. The underground becomes an invisible engine quietly powering everything above it. And what makes this approach different is the engineering philosophy behind it. Instead of accepting that tunneling must be slow and prohibitively expensive, the system focuses on continuous improvement. Faster boring speeds streamline materials automation inside the tunnel construction process itself. Machines are designed to dig, reinforce, and finish simultaneously, reducing downtime and maximizing efficiency. Innovation doesn't stop at the vehicle level. It begins with the machine carving through the earth. That mindset, optimizing every layer of the process, transforms infrastructure from a government burden into a scalable technology platform. And Dubai's geography offers additional strategic advantages. With large stretches of planned development and a commitment to master-planned communities, integrating underground loops during expansion phases becomes even more efficient. Instead of retrofitting after congestion appears, the system can be embedded proactively. Future districts could be designed with subterranean mobility corridors already in place, allowing the city to expand seamlessly without repeating the traffic challenges faced by older global capitals. And there is also a psychological shift that accompanies advanced mobility. When people know they can reach any major hub in minutes rather than hours, behavioral patterns evolve. Meetings become more flexible. Events become more accessible. Tourism becomes more dynamic, allowing visitors to experience multiple destinations in a single day without fatigue. Airports, ports, financial centers, entertainment complexes, all interconnected beneath the surface in a synchronized network that operates like a circulatory system. And the data layer further amplifies performance. Real-time analytics can track passenger flow, optimize routing, and anticipate peak demand before it occurs. Artificial intelligence systems can coordinate vehicle dispatch with precision, ensuring minimal wait times. Because the network operates in a controlled tunnel environment, variables such as weather, accidents, and traffic signals are eliminated. The system becomes a predictable, programmable transportation grid. And scalability is built into the architecture. Initial phases may focus on high-density corridors linking airports to downtown hubs. Subsequent expansions can branch outward, creating a web of connectivity across residential and commercial zones. Each new tunnel segment strengthens the entire system, compounding efficiency gains over time. Unlike surface infrastructure that faces space limitations, underground expansion remains largely invisible and flexible. And energy optimization also becomes a defining factor. Electric vehicles operating in controlled tunnels consume less energy due to reduced aerodynamic drag and consistent speeds. Regenerative braking systems capture energy efficiently in stop-and-go scenarios at stations. Integrated charging infrastructure within the loop ensures continuous operation without long downtime cycles. When powered by renewable energy sources, the network moves closer to a fully sustainable mobility ecosystem. And from a construction standpoint, reduced surface disruption becomes a major benefit. Traditional rail or highway expansion often requires years of visible construction detours and economic slowdown in affected areas. Compact tunneling methods minimize noise, reduce land acquisition requirements, and preserve urban aesthetics. In a city that values design and visual identity, maintaining skyline integrity while upgrading infrastructure offers a powerful advantage. And security and resilience further strengthen the model. Underground systems can be designed with multiple redundancies, independent power backups, and advanced monitoring systems. In extreme weather conditions or surface-level disruptions, mobility continues uninterrupted. This level of resilience enhances the city's global competitiveness, reinforcing its reputation as a reliable hub for commerce and international events. And over time, the presence of an underground mobility grid could influence architectural design itself. Buildings may incorporate direct access points into the loop system. Mixed-use developments might integrate stations into their lower levels, turning mobility into a built-in amenity. Urban density becomes an asset rather than a limitation because transportation capacity scales invisibly beneath it. And as more cities observe the transformation, Dubai could serve as a global showcase for next-generation tunneling infrastructure. Delegations, engineers, urban planners, and policymakers may study the system not just as transportation, but as a new model for city evolution. The underground network becomes proof that modern engineering can solve problems previously considered inevitable. And when innovation operates beneath the surface, it allows everything above it to move more freely, more efficiently, and more intelligently. The convergence of advanced tunneling, electric mobility, AI coordination, and forward-thinking urban planning creates a blueprint for cities that refuse to be constrained by congestion. Dubai's willingness to adopt bold infrastructure solutions positions it not merely as a participant in the future of transportation, but as a defining example of how visionary engineering reshapes the world beneath our feet. And the convergence of advanced tunneling, electric mobility, AI coordination, and forward-thinking urban planning creates a blueprint for cities that refuse to be constrained by congestion. Dubai's willingness to adopt bold infrastructure solutions positions it not merely as a participant in the future of transportation, but as a defining example of how visionary engineering reshapes the world beneath our feet. Once the underground network becomes operational, it begins to influence not only mobility but the way the city functions at every level. Commuters experience travel that is no longer defined by unpredictability. The routine frustrations of traffic signal delays and congestion fade into history, replaced by a streamlined automated system designed for precision and efficiency. The underground loop operates as a living system, continuously optimized through data analytics, sensor feedback, and AI-driven routing. Every vehicle, every station, every segment of the tunnel is interconnected, forming a network that responds dynamically to changing demand, peak travel times, and urban growth patterns. And this level of integration transforms urban life. Workdays are restructured because travel is no longer a bottleneck. Businesses can expand operations knowing that employees can reliably reach headquarters or satellite offices without spending hours in transit. Families gain more time, tourism becomes frictionless, and logistical operations for goods and services achieve unprecedented efficiency. The underground system shifts the value of time, making minutes once lost in traffic available for productivity, creativity, and personal fulfillment. And economic implications extend beyond convenience. Real estate dynamics are reshaped as accessibility becomes multidimensional. Areas previously considered remote can now support high-density residential and commercial developments because the underground loop ensures rapid connectivity. Retail and entertainment sectors benefit from increased foot traffic without the drawbacks of surface congestion. Strategic station placement near business districts, airports, and cultural hubs drives economic activity in a self-reinforcing cycle. Infrastructure is no longer a static cost center but a growth engine. And construction efficiency is another hallmark. By leveraging innovative boring machines that streamline excavation, reinforcement, and finishing simultaneously, tunnel deployment occurs at unprecedented speed. The optimized diameter reduces material consumption while maintaining vehicle capacity and safety. Modular tunnel segments allow for flexible expansion, future-proofing the system for growing demand. Surface-level disruptions are minimized, protecting urban aesthetics and allowing the city to continue operating seamlessly during construction phases. The entire process embodies an approach where technology accelerates delivery without compromising quality, sustainability, or safety. And sustainability is central to every decision. The underground system uses electric vehicles powered by renewable energy, eliminating tailpipe emissions and reducing carbon footprint. Efficient design principles such as regenerative braking and climate-controlled tunnels lower energy consumption and operational costs. Integration with Dubai's broader clean energy initiatives ensures that mobility contributes to environmental goals rather than undermining them. Urban centers benefit from reduced congestion, lower surface pollution, and improved air quality. This alignment between mobility innovation and environmental responsibility creates a model city for the 21st century. And safety and reliability remain paramount. Advanced monitoring systems, automated traffic control, and redundant power supplies ensure that operations maintain the highest standards. In emergency scenarios, the system is designed to maintain functionality while guiding passengers safely. Controlled environments allow for smooth acceleration and deceleration, minimizing discomfort and increasing overall passenger confidence. The result is a transportation network that feels both futuristic and fundamentally secure. And beyond human mobility, the system can expand to logistics and goods movement. Autonomous cargo vehicles could travel through dedicated tunnels, reducing heavy vehicle traffic on surface roads and freeing space for pedestrian cycling and green areas. This dual-use capacity amplifies economic benefits while maintaining a minimal environmental footprint. Cities can optimize the movement of people and goods, simultaneously achieving efficiency that surface infrastructure alone cannot provide. And the psychological impact is profound. Knowing that reliable high-speed underground travel is available changes behavior, expectations, and urban culture. Time previously lost becomes productive, accessible, or leisurely. Daily routines are reimagined. Events, meetings, and social activities become easier to schedule, and urban life becomes less stressful and more predictable. This redefinition of time and mobility fosters a city that is more humane, efficient, and connected. And global implications are clear. As other megacities watch Dubai adopt advanced tunneling networks, they see a replicable model for solving congestion and mobility challenges. By demonstrating that underground transport can be fast, efficient, sustainable, and scalable, Dubai becomes a laboratory for urban innovation. Its success serves as proof that congestion is not an immutable condition, but a problem solvable with vision, technology, and precision engineering. And the adoption of such a system marks a cultural shift as much as a technological one. Transportation ceases to be a constraint and becomes an enabler of opportunity. Urban planners, architects, and developers gain new possibilities in shaping cities. Surface spaces are reclaimed for parks, pedestrian zones, and community hubs. Streets no longer define the limits of connectivity. The underground network redefines them. By integrating advanced tunneling, electric mobility, and AI-driven optimization, Dubai exemplifies a city that does not simply grow. It evolves intelligently, efficiently, and sustainably. And by integrating advanced tunneling, electric mobility, and intelligent urban planning, the underground network transforms the city into a living, adaptive system. Beyond the immediate convenience of fast, reliable travel, the tunnels influence how the city organizes itself, how people move, and how life is experienced above ground. The network redefines spatial relationships, connecting districts that once felt distant and transforming commuting into a seamless, almost effortless experience. People begin to perceive distance differently. Work, leisure, and essential errands become easier to coordinate. The time previously lost in traffic is reclaimed, fueling productivity, creativity, and personal well-being. And infrastructure efficiency becomes a new standard. Traditional projects require years of planning, disruptive construction, and large budgets that often spiral upward. By contrast, the optimized tunnel system is modular, scalable, and technologically precise. Cutting-edge boring machines excavate continuously while simultaneously installing reinforcements and finishing tunnel walls. This method drastically reduces construction time while maintaining safety and structural integrity. Smaller tunnel diameters decrease material usage, lower costs, and minimize disruption to the surface. Each segment becomes a building block for future expansions, allowing the system to grow with the city responding proactively to population density and urban demands, rather than reacting belatedly to congestion. And the economic impact extends across multiple layers. Businesses benefit from predictable travel times, which streamline operations and logistics. Employees spend less time commuting and more time contributing value. Commercial districts gain accessibility without increased surface traffic. Retail and entertainment centers become more vibrant as people can travel efficiently across the city to attend events or visit attractions. Residential development can expand into previously underutilized areas because connectivity is no longer constrained by surface roads. The system turns infrastructure into an engine of growth rather than a cost center. And sustainability is embedded in every aspect of design. Electric vehicles operating in controlled tunnel environments consume less energy than traditional road traffic due to optimized aerodynamics and consistent speed profiles. Regenerative braking and energy recovery systems maximize efficiency. When paired with renewable energy sources, the network operates with near-zero emissions, supporting the city's environmental goals and enhancing air quality. Urban density becomes a strategic advantage rather than a liability as underground mobility reduces the pressure on surface streets and allows more open space for green areas, pedestrian pathways, and leisure zones. And safety and resilience are cornerstones of the network. Automated traffic management systems continuously monitor vehicles, adjust speeds, and prevent collisions. Redundant power systems and emergency response protocols ensure uninterrupted operation, even under extreme conditions. Controlled tunnels eliminate the unpredictability of surface travel. Accidents, weather disruptions, and traffic congestion become non-factors. The result is a transportation system that is not only fast and efficient, but also dependable, instilling confidence in every passenger. An integration with broader city systems further amplifies benefits. Artificial intelligence coordinates vehicle flow, monitors energy consumption, and anticipates peak demand. Passengers experience minimal wait times and maximum reliability. Stations are strategically positioned to maximize access to airports, business hubs, and residential areas, enabling rapid point-to-point travel. Autonomous features allow vehicles to self-route, communicate with station systems, and adjust for real-time demand, ensuring that the network remains fluid and responsive at all times. And logistics and goods movement are natural extensions of this system. Autonomous cargo pods can travel through dedicated tunnel lanes, reducing the number of heavy vehicles on surface roads and freeing streets for pedestrians, cyclists, and electric public transport. Supply chains become faster, more predictable, and less environmentally impactful. By moving goods underground, the city maximizes surface-level utility for community and commercial use, creating a layered urban ecosystem where mobility and commerce coexist efficiently. And psychological and social effects are profound. When travel becomes predictable, safe, and fast, residents' perception of distance, time, and urban scale shifts. People can take on more diverse professional opportunities, engage more frequently in social or cultural activities, and explore the city with greater ease. This fosters a more connected, dynamic, and productive urban environment. Commuting stress is reduced, quality of life improves, and the city becomes a more attractive destination for talent, investment, and innovation. And the model created here offers a blueprint for other megacities facing similar challenges. By demonstrating that high-speed underground electric mobility is feasible, efficient, and scalable, Dubai becomes an example for the world. It proves that congestion is not an inevitable byproduct of urban growth, but a solvable problem when technology, planning, and engineering converge intelligently. And the underground network also catalyzes architectural evolution. Buildings can integrate station access directly into their designs, reducing dependency on surface roads. Mixed-use developments become fully connected hubs of activity. Urban density is leveraged as an asset, not a limitation. Surface areas can be reclaimed for public spaces, parks, and pedestrian-friendly zones, enhancing livability. The tunnels effectively allow the city to expand vertically downward, as well as upward, multiplying functional space without compromising environmental goals or aesthetic appeal. And ultimately, the system becomes more than transportation. It is a framework for rethinking urban life itself, where mobility is seamless, infrastructure is intelligent, and cities operate with the precision, efficiency, and sustainability that modern societies demand. By embedding technology deeply into the city's fabric, Dubai demonstrates how forward-thinking engineering can transform not only how people move, but how a city grows, thrives, and evolves in harmony with its residents.